students. I am RP Umashankar, Department of Mathematics, Base Education. So in this video and few more videos, we'll be discussing about continuity and differentiability, a part of your second year PUC NCERT syllabus. Okay. So before going into definition of continuity, what is continuity of a function, what is differentiability of a function, we have to revise few things related to limit of a function that you have studied in first year PUC. We'll have a quick revision of limit of a function and the standard formulas that you have studied. Then we'll proceed with continuity and differentiability. Okay. Limit of a function. Let us understand limit of a function through an example. Okay. Consider a function f of x, which is x squared minus 4 divided by x minus 2. Take a function x squared minus 4 divided by x minus 2. When x is equal to 2, what happens to f of x? F of x will be 2 squared is 4 minus 4 divided by 2 minus 2. So you are going to get 0 by 0 form. So which is an indeterminate form. We don't know the value of this. So that means f of x is not defined. F of x is not defined for x is equal to 2. When x is equal to 2, we observe that f of x has no value. Therefore, f of x is not defined at x is equal to 2. Okay. Let us take when x not equal to 2, what happens? F of x, which is x squared minus 4 divided by x minus 2. Now I can simplify this as x minus 2 into x plus 2 divided by x minus 2. So x minus 2 cancels because we have assumed that x is not equal to 2. When x is not equal to 2, x minus 2 is a non-zero quantity. So I can cancel it off. So you get an equivalent expression x plus 2. So for all values of x which are not equal to 2, f of x is x plus 2. Now we have already seen that function is not defined that x is equal to 2. Now let us see what is the value f of x takes whenever you give values of x close to 2. Okay. For that, we'll have a table. We know that function is not defined at x is equal to 2. So let us see what happens when you give values of x which are close to 2. Close to 2, close is a relative word. So I'll simply start values of x from say 10. If x is equal to 10, value of the function is 12. Then I'll give 5, value of the function is 7. For x is equal to 3, value of the function is 5. 2.1, value of the function is 4.1. You can still go closer to 2. 2.0001, value of the function becomes 4.0001. You can still go close to 2. You can even give 2.000001. You can calculate the value of f of x. For observation, this is sufficient. Now I'll give the value of x, another set of values. I will start from say minus 5. X is equal to minus 5. F of x will be minus 3. X is equal to 0. F of x is 2. X is say 1.5. F of x is 3.5. 1.99. F of x is 3.99. You can go very close to 2. But always remember, you should not give x is equal to 2. So value will be 3.999. From the table, what is the observation we are making? We are not giving x is equal to 2. Basically, that is the assumption when x is not equal to 2. From the table, we observe that though the value of the function does not exist at x is equal to 2, f of x exists for values of x which are close to 2. Whether that value is more than 2 or lesser than 2, value of the function exists. Function is not defined at x is equal to 2, but function is defined in the neighborhood of the point x is equal to 2. What do you mean by neighborhood? Slightly more than, slightly lesser than the reference point. Here the reference point is 2. Slightly more than 2, slightly more than 2. Function takes the value which is almost equal to 4. Slightly lesser than 2. Function takes the value again which is almost equal to 4. 3.999, 4.0001 is almost equal to 4. So we can say this, as and when x approaches 2, as and when x approaches 2, f of x is taking value close to 4. This we write it as limit of the function f of x as x tends to 2 is equal to 4. As and when x takes values close to 2, f of x takes values close to 4. This is your limit of the function. So basically, by finding limit of a function, what is that we understand? We understand the behavior of the function in the neighborhood of a point. At that point, whether the function is defined or not defined, we are least bothered. In the neighborhood of the point, what is the value of the function? Neighborhood of the point means slightly more, slightly greater value, slightly lesser value. With respect to the reference point, what is the behavior of the function? This is what we understand by finding limit of the function. In the table, what is the observation? In the first case, we have given values of x. X values is approaching 2 through the values which are more than 2. In the second case, values of x are approaching 2 through the values which are lesser than 2. In the first case, that is when you give values of x which are more than 2, the limiting value obtained, we refer it as right hand limit. Second case, when you are given values of x which are lesser than 2, the limiting value obtained is your left hand limit. Left hand limit, right hand limit. In first year PUC, we have studied that limit of a function exists only when both LHL, RHL exist and are equal. Observe that RHL is almost equal to 4. What is LHL? Almost equal to 4. Both LHL and RHL are approaching the same value. Therefore, limit of the function f of x exists and it is equal to 4. So this is basically how we define limit of the function. In general, we denote the limit. Suppose a general function is taken, f of x. We write it as limit x tends to a, f of x is equal to f. What is the meaning of this? As and when x approaches a, f of x takes values close to L, or in the neighborhood of the point x is equal to a. In the neighborhood of the point x is equal to a, f of x takes values which are very close to L. This is how we define limit of the function. Now, with respect to your LHL and RHL, how we have defined LHL and RHL? In general, LHL means, suppose A is the reference point. How to define left hand limit? It is limit x tends to A through the values which are lesser than A. That we denote it as A minus f of x. This is how we define left hand limit. Every time while doing the problem, we cannot construct the table and observe what happens to the function. There must be an algebraic way of calculating the left hand limit and right hand limit. How to calculate limit? Basically, we are giving values of x which are lesser than a. So, to cover all those things, we have to replace x by a minus h. A minus h. Whenever h is positive, a minus h always gives you a value which is lesser than a. And those values must be close to a. To cover that, we have to take h tends to 0. Limit h tends to 0, f of a minus h will give you left hand limit. This is how we calculate left hand limit. What about right hand limit? Similar to left hand limit, we calculate the right hand limit. What is right hand limit? Right hand limit is nothing but limit x tends to a plus f of x, which is equal to limit f of, what is the meaning of x tends to a plus? X is approaching a through the values which are more than a. That can be easily put in the function as f of a plus h. If h is positive, a plus h always gives you a value which is more than a. But we don't want all those values which are more than a. We want values which are close to a. For that, we take h tends to 0. So this is your RHL. RHL is limit h tends to 0, f of a plus h. Very, very important formulas. One is left hand limit. Limit h tends to 0, f of a minus h. RHL, limit h tends to 0, f of a plus h. Then, most important note, limit of a function exists only when both LHL and RHL exist and are equal. We say that limit of a function exists only when LHL, RHL both exist and are equal. If they exist and if they are different, limit does not exist. Or if one of the LHL, RHL, if they don't exist, then also we say that limit does not exist. So this is basically a brief introduction to limit of a function. What the students should remember? Limit x tends to a, f of x is equal to L means what? Whenever x approaches a, f of x takes values which are close to L, or value of the function f of x is equal to L in the neighborhood of the point x is equal to a. Behavior of the function, by finding the limit of the function, what do we understand? We understand the behavior of the function in the neighborhood of a given point. Here the given point is a. In the neighborhood of the given point, how f of x behaves. If you want to calculate that, you have to find out the limit of the function. Limit x tends to a, f of x is equal to L gives you the idea of the value of f of x, behavior of the f of x in the neighborhood of the point x is equal to a. Okay, this is the most important thing a student has to remember. Then after this, in first year PUC, you have done some standard results. What are those standard results? Let us just mention all those results. First one, limit x tends to a, x to the power of n minus a to the power of n divided by x minus a is equal to n, a power n minus 1. Then you have limit theta tends to 0, sin theta divided by theta is 1, where theta is measured in radians. Next one, limit theta tends to 0, tan theta by theta is equal to 1. Again, theta is measured in radians. Next one, limit n tends to infinity, 1 plus 1 by n whole to the power of n is equal to e, where e is an exponential number. Limit x tends to 0, 1 plus x whole to the power of 1 by x is equal to e. These are all some special limiting formulas. Limit x tends to 0, a to the power of x minus 1 divided by x is equal to log a to base e. Limit x tends to 0, log of 1 plus x divided by x is equal to 1. These are all some formulas that we have studied in our first year PUC. Okay, just make a note of all these formulas. Very useful for our calculations. I hope you have noted down all the formulas. Let us take one general example or general idea. See, whenever you want to purchase you means your family, your father, mother, if they want to purchase a new flat or a new house, what is that they are going to do? They are going to ask some broker about the areas or what are the availability of flats and all those things. He will come out with, say, 2 or 3 cases or 4 cases or 4 places where the available flats are there. Before seeing the flats, before seeing the flat or before going to a place where you are purchasing, where you want to purchase, so what your family will do? They'll always observe the neighborhood, the area. First, they'll verify what is the area, how the area is. Then they'll see the actual locality. Then they'll see the neighbors, actual neighborhood. Okay, who are all staying, what kind of neighborhood it is. Then they will enter the apartment where the flat is there. Then they'll do all these vastu research and then they'll decide, then purchase one flat. This is what everybody will do. Okay, in mathematics also, we do the same thing. Before we go into continuity, differentiability and concepts involving function, we always start with this limit of a function. Why? By finding the limit of the function, what do we understand? We understand the behavior of the function in the neighborhood. Whether function exists at the point or not, that is a different question. First, we are verifying what is the behavior of the function in the neighborhood of the point. Then we'll go into the behavior or the value of the function at the point. Suppose you decide on one locality or one apartment you purchase. Okay. If the behavior of whatever your behavior, if it matches with the neighbor's behavior, then everything will be fine. Correct? No problem will be there, no mental tension will be there. Your life will be fantastic and beautiful. When it will happen, behavior of your behavior matches with the behavior of your neighbors. Okay? In mathematics, whenever the behavior of the function in the neighborhood, what is the behavior of the function in the neighborhood? Suppose I take the reference point as a, limit x tends to a f of x. This gives you the behavior of the function in the neighborhood of the point x is equal to a. If it matches with our behavior, what is that our behavior? Our behavior or value of the function at the point. In mathematics, we say our behavior is value of the function at the point. If these two matches, then everything is fine. What is that everything is fine? We say in mathematics as function is continuous. This is the definition of a continuous function at a point x is equal to a. If you want to say a function is continuous at x is equal to a, limit x tends to a, f of x must be equal to f of a. Okay? Behavior of the function in the neighborhood of a point, if it matches with the behavior of the function at the point or value of the function at the point, we say that function is continuous. Okay? Our behavior, if it matches with the behavior of our neighbor, everything will be very, very smooth in our life. Similarly, in mathematics, value of the function at the point, if it matches with value of the function in the neighborhood of the point, we say that everything is fine. Or in terms of the mathematical terminology, we say that function is continuous. I hope you understood the definition of continuous function. Continuous function. A function is the definition. A function f of x is said to be continuous at x is equal to a. At x is equal to a. Said to be continuous at x is equal to a if limit x tends to a, f of x is equal to f of a. Limit x tends to a, f of x is equal to f of a. Okay? The moment I say limit x tends to a, f of x, that means I am saying that limit exists. Limit exists means what? Left hand limit is equal to right hand limit. So same definition, I can just write it in a different way. Limit x tends to a minus f of x, that is left hand limit, is equal to limit x tends to a plus f of x. Right hand limit is equal to f of a. If this happens, function is continuous at x is equal to a. When do we say that function is discontinuous or not continuous? There is a definition of continuous function. Suppose f of a does not exist. We cannot compare. So then function becomes discontinuous. So f of a does not exist, function becomes discontinuous. Then left hand limit not equal to right hand limit. That means limit does not exist. Then also function is discontinuous. F of a exists, limit exists, both are not equal. Then also we say that function is discontinuous. So a function f of x is discontinuous. At x is equal to a if any one of the following conditions, Any one of the following hold. F of A does not exist. F of A does not exist. That means function is not defined that x is equal to A. If that is the case, function is discontinuous. Then limit x tends to A, f of x. Limit x tends to A, f of x does not exist. Limit x tends to A, f of x does not exist. That means left hand limit is not equal to right hand limit. Then also function is discontinuous. Third one is limit x tends to A, f of x exists but not equal to f of A. Not equal to f of A. So any one of these conditions, if it holds, function is called a discontinuous function, or we say that function is not continuous, discontinuous at the point x is equal to A. So this is the definition of continuity of a function at a point, discontinuity of a function at a point. And once again, go through the definition. A function f of x is said to be continuous at a point x is equal to A if limit x tends to A, f of x is equal to f of A. That means we are saying f of A must exist, limit must exist, and both the values must be one and the same. The moment you say limit exists, that means LHL is equal to RHL. You can say LHL is equal to RHL is equal to value of the function at the point. If this happens, function is continuous at the point x is equal to A. In this, if any one is not satisfied, one of the equality, if it doesn't happen, then the function is discontinuous. That means when f of A does not exist, there is no question of comparison. Function is discontinuous. If limit does not exist, there is no question of comparison. Function is discontinuous. When both exist and they are different, then also function is discontinuous. Okay. So this is the definition of a continuous function at a point x is equal to A. Suppose this definition holds good for all the points in a given domain. Suppose I take the domain as set of real numbers. If this definition holds for each and every point in the domain, that is real numbers, then in general we say that function is continuous. We don't mention any point. If I say function is continuous, that means it is continuous at each and every point in the domain. Okay, that is the general definition. Suppose in the examination, if they ask, define a continuous function, that means you have to define the continuity of a function at each and every point. How to define that? If a function f of x is continuous at all points in a given domain, that domain may be anything. It may be an interval, or it may be set of integers, or it may be set of rationals or reals. If nothing is mentioned, we always take the domain as set of reals. Given domain, the function is continuous at all points in a given domain, then we say that f of x is continuous. F of x is continuous function. Remember, continuity of a function is defined at a point. Point is very much important. If the definition holds good for all points in the domain, then we simply say that function is continuous. Okay? The domain may be anything. It may be an interval, it may be set of reals, or it may be any given set. If the function is continuous at each and every point in a given domain, if the definition of continuity of a function at a point holds for each and every point in a given domain, we simply say that function is continuous. Okay. After taking this definition, let us just take one or two examples how to verify continuity of a point, continuity of a function at a given point. Let us take the function as f of x is equal to 2x minus 1. Let us take the reference point as, say, 1. F of x is 2x minus 1. Let us verify the continuity of the function at x is equal to 1. I will state this as a problem only so that you can write it down. Verify the continuity of f of x, which is equal to 2x minus 1 at x is equal to 1. This will be a typical problem on continuity of a function. Solution. Given function is 2x minus 1. Let us take the reference point as a. What is the reference point? 1. A is equal to 1. What is the definition of continuity? Continuous function. Limit x tends to a, f of x is equal to f of a. Okay. This is the definition of continuity of a function at a point x is equal to a. That means you have to find out the limit. You have to find out the value of the function at the point. If they are equal, then function becomes continuous. How to find out this limit? Let us go for left hand limit. Because we don't know whether the limit exists or not. We don't know that. So we should find out LHL. We should find out RHL. Then we should conclude whether the limit exists or not. So left hand limit is equal to, what is this left hand limit? How to calculate left hand limit? We already seen how to calculate left hand limit. Limit h tends to 0, f of a minus h. This gives you left hand limit. How to calculate right hand limit? Right hand limit RHL is equal to limit h tends to 0. Limit h tends to 0, f of a plus h. That is your right hand limit. So in this case, left hand limit is limit h tends to 0, f of a. What is a? 1. 1 minus h. This is equal to limit h tends to 0. What is f of 1 minus h? 2 times 1 minus h minus 1. This is equal to, put h is equal to 0. Apply the limit. Generally, h tends to 0 means what? H is almost equal to 0, but not equal to 0. Correct? For all practical purposes, whenever we are doing a problem, h tends to 0, we actually put h is equal to 0. Because h tends to 0 means what? It is almost 0. For practical purposes, we take h is equal to 0. If you put h is equal to 0 or apply the limit h tends to 0, what is that you are going to get? 2 minus 1, which is equal to 1. This is your LHL. Let us calculate similarly the right hand limit. What is RHL? What is RHL? RHL is equal to limit h tends to 0, f of a plus h. This is equal to limit h tends to 0. What is a? A is 1 plus h. This is equal to limit h tends to 0. What is f of a plus h or f of 1 plus h in our problem? 2 times 1 plus h minus 1. Apply the limit. If you apply the limit, that means take h tends to 0. What is that you are going to get? You are again going to get 1 as the answer. What is the conclusion? LHL is equal to RHL. LHL is equal to RHL is equal to what is the value of God? 1. Therefore, limit x tends to 1, f of x exists and it is equal to 1. That is the conclusion. Limit x tends to 1, f of x is equal to 1. Now, take the function f of x. What is f of x? 2x minus 1. Directly put x is equal to 1 because we want the value of the function at the point. So f of 1 is equal to what you get? 2 into 1 minus 1. How much you get? 2 minus 1. Again you are getting 1. Observe these two results. Therefore, I can conclude limit x tends to 1 f of x is equal to f of 1, which implies f of x is continuous. F of x is continuous at x is equal to 1. F of x is continuous at x is equal to 1. This is what we should do for all problems of this type. We have to verify whether the function is continuous at a given point. For that, what is it that we should do? We have to find out left hand limit. We have to find out right hand limit. If they are equal, that means limit exists. Then we should find out what is the value of the function at the point. If limiting value and the value of the function at the point, if they are one and the same, then the function becomes continuous. Okay? I hope you understood the method of evaluation. Just go through this. By pausing your video, you can just record, you can write down these things. This is the method we are going to follow for almost 90% of the problem which are in continuity, which are related to continuity in your NCERT textbook. Evaluate left hand limit, evaluate right hand limit. Then what is the value of the function at the point? If all the three are same, function is said to be continuous. Function is said to be continuous. Now we'll take one more problem. Verify the continuity of the function. F of x is equal to, say, x squared. X squared at x is equal to 0. At x is equal to 0. Let us see how to calculate, how to verify the continuity of the given function. Same procedure, no changes. F of x is equal to given function is x squared. The reference point is 0. We'll first calculate left hand limit. What is left hand limit? Limit x tends to 0 minus f of x. This is the meaning of left hand limit. How to calculate left hand limit? Limit h tends to 0. F of 0 minus h. Limit h tends to 0. What is f of 0 minus h? F of minus h. F of minus h is minus h whole square because our function is x squared. The f of minus h is minus h squared. If you apply the limit, you get 0. As h tends to 0, minus h squared goes to 0. Now what is that we should do? RHL. What is our right hand limit? Limit x tends to 0 plus f of x, which is equal to limit h tends to 0, f of 0 plus h, which is equal to limit h tends to 0. What is f of 0 plus h? F of h. What is f of h? H squared. If you apply the limit, you get 0. RHL is also 0. So left hand limit is equal to right hand limit is equal to 0. Therefore, I can write limit x tends to 0. F of x is equal to 0. You can put a box for this. So that means limit exists and the limiting value is 0. This is the first step of your problem. Now what is it we should do? What is the function? Function is x squared. What is the value of the function at 0? So directly put x is equal to 0. What is that you are going to get? You are going to get f of 0 is equal to 0. Therefore, what is the conclusion? Limit x tends to 0, f of x is equal to f of 0, which implies f of x is continuous. F of x is continuous at x is equal to 0. F of x is continuous at x is equal to 0. Suppose similarly you do the problem for all other points, say x is equal to 0, 1, 1.1, 0.1, minus 1, minus 2, minus 2.3. Likewise, if you cover all real numbers, then in general we can say that function is continuous. Okay, got it? The difference between continuity at a point and in general continuous function. In general, continuous function means it is continuous at each and every point in the given domain. While doing the problem, generally it will be with respect to a given point. Find out LHL, find out RHL, find out the value of the function at the point. If all three are one and the same, function is continuous. Otherwise, function is discontinuous. Okay, let's go through the problem. While I'm doing the problem, you need not do it. After the problem, I'll just give some time so you can just copy down the problems. I hope you are understanding what I am explaining. Okay? Any doubts that you get can be clarified later on. Now let us take one more problem. Verify the continuity of the function. Verify the continuity of the function. Of the function modulus of x divided by x at x is equal to 0. At x is equal to 0. Solution. The given function is f of x is equal to modulus of x divided by x. The reference point is a is equal to 0. 0 is the reference point. Same procedure. Let us find out left hand limit. What is left hand limit? Limit x tends to 0 minus f of x. What is the meaning of this 0 minus? 0 minus means x tends to 0 through the values which are lesser than 0. How to calculate this? Limit h tends to 0, f of 0 minus h, which is equal to limit h tends to 0. What is f of 0 minus h? 0 minus h is minus h. What is f of minus h in our problem? Modulus of minus h divided by minus h. The h that we introduce, while calculating left hand limit and right hand limit, students remember that h is always positive. H value is positive. The h that we have introduced in LHL and RHL, don't think that this h I am speaking. This is left hand limit. This is not the h I am speaking. I am speaking about this h. This h is always positive. So this is equal to limit h tends to 0. What is modulus of minus h? H divided by minus h. H is positive, minus h is negative. Modulus of a negative number, modulus of a negative quantity is the equivalent positive quantity. Modulus of minus h is h divided by minus h. H cancels. You get left hand limit as minus 1. Let us calculate right hand limit. What is right hand limit? Limit x tends to 0 plus f of x. Here, what is the meaning of x tends to 0 plus? Once again, I am I'm explaining. 0 plus means you are giving values of x through. You are approaching 0 through the values which are more than 0. X is approaching 0 through the values which are more than 0. How to calculate? This limit h tends to 0. F of, you have to replace x by 0 plus a positive quantity h. X must be replaced by 0 plus h. This is equal to limit h tends to 0. Limit h tends to 0. What is f of 0 plus h? 0 plus h is nothing but h. What is f of h? According to the given function, modulus of h divided by h. Since h is positive, modulus of h is h divided by h. H cancels. You get 1. What is the observation? Left hand limit is -1, right hand limit is +1. LHL not equal to RHL. This implies limit, you can say limit x tends to 0, f of x does not exist. Does not exist. Therefore, you can say that function is discontinuous. F of x is discontinuous at x is equal to 0. Student may say that, sir, why we calculated left hand limit, right hand limit? So clearly the function f of x is modulus of x by x. If you put x is equal to 0, it is in 0 by 0 form. It is not defined. So why we calculated LHL and RHL? Fantastic, good observation. But if they give the problem like this, same problem, if they give it like this, just change the way they will give the definition. Suppose if they give f of x is equal to modulus of x by x for all values of x not equal to 0, 1 at x is equal to 0. If I change the question like this, then observe that they have given the value of the function at x is equal to 0, which is 1. Then you have to verify LHL and RHL. Okay, so that's why I calculated LHL and RHL for your original problem. What is that original problem? I'm changing to original problem. Continuity of f of x is equal to modulus of by x, modulus x by x at x is equal to 0. Okay, your observation, the function is not defined at x is equal to 0 in the beginning. It is a good observation. But if they give the function in a different way, if they give values of the function, value of the function at x is equal to 0, then you have to calculate LHL and RHL. Just for example, I have given this method. Okay, I hope you understood. Here left hand limit is -1, right hand limit is +1. Therefore, limit does not exist. If the limit does not exist, function is discontinuous. Okay. Through these 3 examples, I hope you have understood what is continuity of a function at a point. How to calculate, how to verify continuity of the function at a point. Okay. Now what we do is, we take a few standard results. Okay, there are few functions which are always continuous in a given domain. In a given domain means generally we take set of real numbers. So standard functions are there. We show that those functions are continuous. Then we'll proceed with other types of problem. Before going into those standard functions or showing that those standard functions are continuous algebraically, what about how to identify a function continuous geometrically? That's the next one. Okay. So geometrically, it is very easy to identify a continuous function. We know that for every function, there is a graph associated. Okay, for every function, you take any function, f of x is equal to x, you can plot it on a two-dimensional graph, correct? F of x is equal to x results in a straight line. Suppose you take f of x is equal to x squared, you're going to get a parabola. So every function has a graph, a equivalent graph with that. Okay, how to identify whether the function is continuous or not? Very simple. If you can plot the graph, if you can write the graph without lifting your hand, or if the graph doesn't have any gaps, breaks in it, the function is continuous. Okay, let us take some examples, some graphical examples. We'll take it, then we'll proceed with our standard results. The graphs that I am going to write now, they're all known to you. You know all these graphs. First example, I can take it as standard examples. First one, f of x is equal to x. F of x is equal to x. Suppose you plot this on a graph sheet. F of x is equal to x means you can even take it as y is equal to f. Y and f of x are one and the same. Okay. However you want, you can write down. If I take y is equal to x, clearly we see that it is a straight line passing through origin with angle 45 degrees. Okay. Clearly we can see that I can write this line without lifting my hand. There are no gaps in it. The line is continuous. Therefore, the function is continuous. If you can plot the graph without lifting your hand, the function becomes continuous. Let us take f of x is equal to x squared. It is a parabola. You can draw the graph without lifting your hand. F of x is equal to x squared. Third one, f of x is equal to x cubed. How the graph of x cubed? If you consider the domain as set of real numbers, x cubed graph may look like this. We can see that function is continuous. I am writing the graph without lifting my hand. There is no gap, there is no break in the drawing of the graph. F of x is equal to sin x. Sinusoidal wave, sinusoidal function. How the function will be? You can see that. You can draw the graph without lifting your hand. It is continuous. F of x is equal to cos x. F of x is equal to cos x. How the graph will be? This is the cos x graph. We observe that it is continuous. F of x is equal to e to the power of x. F of x is equal to e to the power of x. How the graph will be? Again, a continuous graph, no gap, no breaks in between. F of x is equal to e to the power of minus x. How the graph will be? This is the graph of e power minus x. Few more examples. F of x is equal to modulus of x. How the graph will be? F of x is equal to modulus of x. Standard function. You have studied in your first year PUC. You can write the graph without lifting your hand. Then f of x is equal to, suppose I take tan x. F of x is equal to tan x. How the graph will be? F of x is equal to tan x. Tan x graph looks like this. We clearly see that at pi by 2 and all odd multiples of pi by 2, function is not defined. There exists no function at x is equal to pi by 2, 3 pi by 2, 5 pi by 2, likewise. So it is an example for discontinuous function. Tan x is discontinuous at pi by 2, 3 pi by 2 and in general odd multiples of pi by 2. Suppose you want to make tan x continuous, what to do? Consider the domain. Consider the domain in such a way that these points are not there in that domain. Pi by 2, 3 pi by 2, minus pi by 2, odd multiples of pi by 2. If you remove from the domain, then the tan x becomes continuous. Okay? The tan x in general it is discontinuous function, but you can make it as continuous by removing the points of discontinuity. These points, if you don't consider in your domain, then tan x becomes continuous. Okay? Next one. F of x is equal to greatest integer function. First year PUC you have studied this greatest integer function, bracket x, bracket function, how the graph will be. It looks like a step function. It is like a step. Clearly we see that it is discontinuous at all integral values. We'll actually prove this result, but as a graph, you just consider. Bracket x function, it is discontinuous at all integral values. At all integral values, the function is discontinuous. Few graphical examples. So through graph, it is very easy to identify continuous function. If you can draw the graph without lifting your hand, the function becomes continuous. If while drawing the graph, if there is a gap in the graph, if there is a break in the graph, or if you cannot write it continuously, then the function is discontinuous. Okay? Few standard examples, few graphs. Try to remember these. Modulus of x function, this greatest integer function. These are all functions you have studied in your first year PUC, standard graphs. Okay? Whatever the graphs we have written here, quite a few functions. Now we'll prove that they are continuous algebraically. How to show that? For example, sin x. You have to show that sin x is a continuous function. Is the book work in your NCERT textbook. Okay. So then we'll show sin x is continuous. Then bracket x function, that is greatest integer function, as discontinuous function algebraically. Okay, let us take one of the book works from NCERT textbook. Okay, prove that a polynomial function. Prove that a polynomial function is continuous. Prove that a polynomial function is continuous. Important book work. They have given this in examination also. Solution. Observe that we have to prove that a polynomial function is continuous. It is not continuous at a point and all those things. In general, we have to prove that polynomial function is continuous. Since they have not mentioned anything about the domain, we should consider the domain as set of real numbers. That means for each and every real number, you have to show that polynomial function is continuous. How to do it? Consider f of x is equal to a polynomial function a0 plus a1x plus a2x squared plus dot 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 an x to the power of n. This is a polynomial function. Let x is equal to c be an arbitrary real value. Arbitrary means any real value. There is no restriction. Let x is equal to c be an arbitrary real value. Now, let us calculate limit x tends to c f of x. This is equal to limit x tends to c. F of x is a naught plus a1x plus a2x squared plus dot 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 an x to the power of n. This is equal to limit x tends to c, or you can directly apply the limit. Since polynomial function, the function that we have considered is a polynomial function. This is defined for each and every real value. The polynomial function exists for each and every real value. Therefore, if you apply the limit, you get a naught plus a1c plus a2c squared plus dot 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 an c to the power of n. This is equal to, I can replace this entire expression by f of c. Because polynomial function exists or defined for each and every real value, limiting value is equal to f of c. So limit x tends to c f of x. We have clearly shown that it is equal to f of c. This implies the function f of x is continuous. Is continuous at x is equal to c. Since c is arbitrary, this c, the point c that we have taken is arbitrary. Arbitrary means there is no restriction on the choice of x is equal to c. This result can be, you can verify this result for any real value. So in general, we can say that function is continuous for all real values. X is equal to c is an arbitrary value. If you prove a result for an arbitrary value, we can conclude the result for all real values. So f of x is continuous at x is equal to c since x is arbitrary. Since, I'll write it somewhere here, since x is equal to c is arbitrary, f of x is continuous. F of x is continuous for all real values. This is your standard result. A bookwork in your NCERT textbook. A polynomial function is a continuous function. Polynomial function, the moment we say polynomial function, if the polynomial function is of degree 1, then it becomes a linear function, quadratic function, cubic function. All things are taken care. The moment I say polynomial, linear function, quadratic, or in terms of graph, if I speak, set of straight lines, then set of parabolas, everything is taken care by this one book word. Polynomial function is a continuous function. Remember this, very, very useful result. Okay, very simple to prove. Take the function f of x as a naught plus a1x plus a2x square up to anx to the power of n. Let c be an arbitrary value. Take some randomly chosen value, say c. Find out the limit. Here I have not calculated LHL and RHL because we know that polynomial function is defined, exists for each and every real value. Directly we have applied the limit. Okay, that limiting value is so much. This can be replaced by f of c. So definition of continuity of a function at a point. What is the definition? Limit x tends to c, f of x is equal to f of c holds. Therefore, we can conclude that function is continuous. Since x is equal to c is an arbitrary value, we can say that in general, a polynomial function is continuous. That means it is continuous for every real value. Okay, this is your standard bookwork. Now, remaining things, remaining book work, remaining standard book works, I'll be doing in the next session. Okay. So, whatever, go through the sessions once again. Wherever you want to write down, you can pause this session and write down all the details. In the next video, we'll be taking up few more standard examples. Then we'll move on to solving a few problems related to continuity. Thank you.